Hi, this is Mrs. Merrill. Today we're going to be talking about learning objective 3.1, which is using inductive reasoning to identify patterns and make conjectures. We're also going to be finding counterexamples to disprove conjectures. The vocabulary for today: inductive reasoning, conjecture, and counterexample. Now let's try it. I want you to look at the example here, and I want you to try to identify a pattern, and then I want you to use that pattern to make a conjecture or to make a conclusion. So, find the next item in the pattern. January, March, May. Do you see a pattern? Well, they're alternating months of the year. So then I recognize that pattern, so then my answer or my conjecture, my conclusion is the next month would have to be July. Take a look at this one, very similar. Find the next item in the pattern. 7, 14, 21, 28. Use inductive reasoning. Inductive reasoning is reasoning where you look for a pattern or you base it on an observation. So I'm looking, observing, I see, oh, those are multiples of 7. So then I use that idea, I use my pattern that I came up with in my mind to make my conjecture, and the next multiple is 35. Take a look at this. Here we have some shapes. You're supposed to figure out the next shape in the pattern. Again, when I use inductive reasoning is reasoning based on what you see or observe. In other words, you're looking for a pattern. You're observing a pattern, and then you will apply that pattern to formulate your conjecture, which of course is your conclusion. And you'll see in this case, the figure is rotating 90 degrees counterclockwise each time, and then you get the picture there at the bottom. Here we have another example of using inductive reasoning to make conjectures. I want to again look at the numbers, try to find a pattern. Again, inductive reasoning is what I see or observe. So I'm looking, I'm observing, oh, I notice a pattern. It looks to me like we are dealing here with one more zero after the decimal point each time. So the next item would have 3 zeros, and there is my conjecture, which again is my conclusion based on what I have seen or observed. When several examples form a pattern and you assume the pattern will continue, you are applying what we call inductive reasoning. Inductive reasoning is the process of reasoning that a rule or statement is true because specific cases are true. You may use inductive reasoning to draw a conclusion from a pattern, which is what we've been doing, and then a statement you believe to be true based on your inductive reasoning is called your conjecture. Let's try it again. I want you to try to figure out a pattern that is observable, and then apply that to get your answer or conjecture. The sum of two positive numbers is blank. All right, so let's think of some examples of adding two positive numbers. Remember, sum means add. So 1 plus 1 is 2. 3.14 plus 0.01 equals 3.15. 3,900 plus 1,017 equals 1,003,917. What do you notice about the answers to all of those when I'm adding two positive numbers? I do see a pattern. It looks to me like the answers are all positive, and so that is my conjecture. Again, a conjecture is your conclusion based on what you see or observe, and that is inductive reasoning. So my answer, positive. Here's another example. Same thing. I want you to try to think of a pattern, use inductive reasoning, look for a pattern, see what you observe, and then use that in order to formulate your conjecture or your conclusion. The number of lines formed by 4 points, no 3 of which are collinear, is blank. So I need, on my paper, I need to put 4 points, and 3 of them cannot be on the same line. So I'm going to draw that. I'm going to draw my 4 points, make sure that no 3 are on the same line, and then I'm going to count the number of lines that are formed. Remember, between 2 points, you form a line. So connect 2 points to form a line. Notice I am coming up now with my conjecture based on what I see from my drawing. And so I figure out that I can come up with 6 different lines. Again, that is inductive reasoning. Inductive reasoning is based on what you see or observe, and then you use that to make your conjecture. You use that to make your conclusion. Here's another. the product of two odd numbers is blank. All right, well, I better try some. So two odd numbers. So I got it, the product, that means times. So 1 times 1 is 1, okay. 3 times 3 is 9. 5 times 7 is 35. What do I notice about 1, 9, 35? Oh, I notice they are all odd. So my conjecture is the product of two odd numbers must be odd. Again, a conjecture is your answer, your conclusion based on what you see or observe. And remember, when you come up with a conclusion based off what you see or observe, that is inductive reasoning. Now that contrasts with deductive reasoning, which is the other type of reasoning. Deductive reasoning is reasoning that you come up with a conjecture based on solely fact. In other words, deductive reasoning is reasoning that comes from fact only. Now, let's take a look at this one. Here's an example from biology. The cloud of water leaving a whale's blowhole when it exhales is called its blow. A biologist observed blue whale blows of 25 feet, 29 feet, 27 feet, and 24 feet. Another biologist recorded humpback whale blows of 8 feet, 7 feet, 8 feet, and 9 feet. Make a conjecture based on this data. Now, once again, we are looking at our data. We are looking for some sort of pattern that's observed, and then we're going to use that to make a conjecture, to make a conclusion. So I'm looking at the chart and I'm thinking, well, first of all, I know that the blue whale blows are definitely higher. Look at that. 25, 29, 27, 24. I could also say, in contrast, the humpback whale then, its blows would be smaller than the height of the blue whale blows, because look, 8, 7, 8, and 9. Here are some examples of some conjectures that could be made. Again, what you need to understand is that your conjecture may not be the same as someone else in class. We may observe the same thing, but come up with different conjectures. Which brings me to the point that not every conjecture that you make is going to be true. Inductive reasoning sometimes will lead us to incorrect conjectures. So here you see, look at that, the last two. The height of the blue whale's blow is about 3 times greater than the humpback's whale blow. And then the height of the blue whale's blow is greater than the humpback whale's blow. So again, I came up with that bottom conclusion. So again, not everybody's conclusions will be the same. And they may not be correct. Again, the conjecture could be wrong if it's based on inductive reasoning. Here's another example. Make a conjecture about this table. This is the average whale lengths comparing a female to a male. Look at the chart there. You see the average length of the different female whales, and you see 49, these are in feet, 49, 51, 50, 48, so on. And then look at the contrasting lengths of the male whale, and you see 47, 45, 44, and so on. Make a conjecture. Well, what are you thinking? Well, their conjecture is in 5 of the 6 pairs of numbers above, the female is longer. So maybe your conjecture is the female whale would be longer than the male. And that could be your conjecture based on inductive reasoning. Here we have a couple things that you need to make sure that you remember when you base your answer, when you base your conjecture on inductive reasoning. It doesn't always turn out to be true. To show that a conjecture is always true, you have to prove it. Again, if your conjecture, if your conclusion is based on inductive reasoning, it could be wrong. So to show that a conjecture is false, what we do is we try to find at least one example where the conjecture would not be true, and that is called a counterexample. So in order to prove my conjecture, what I do is I look for cases where it could be false. If I find one, then I know that my conjecture is wrong. So basically what I'm doing is I'm trying to find a counterexample. Now, what can a counterexample be? Well, it could be a drawing, a statement, it could be a number. Now let me show you here what I mean by that. All right, so our process for using inductive reasoning has 3 steps. Number 1, we look for a pattern. Now remember, we're trying to observe something, some pattern about what we see. And then step 2, we make a conjecture, we make a conclusion based on the pattern that we see or observe. And then the last step, which is what we're going to practice now, is I've got to decide if my conjecture is really true. And so to prove it, what I do is I try to look for a case where it's false. In other words, I try to find a counterexample. All right, so here we go. So suppose I say that for every integer n3 is positive. Suppose that's my conjecture. In other words, I think that's true. For every integer, if I cube it, it's going to be positive. All right, so if that's my conjecture, if that's the conclusion that I made based off of inductive reasoning, some pattern that I saw or observed, then I've got to try to see if that's really right. Okay, so what I'm really doing is trying to see if it's really wrong. In other words, I'm looking for a counterexample. So I picked some numbers to substitute in. I tried 1. Oh, that worked. What is 1 cubed? That's 1. So that worked. Okay, well, that looks good. Then I try again. Now I tried -3. Uh-oh. What is the quantity -3 cubed? Oh, it's -27. -27 is not positive. So, my conjecture is wrong. For every integer n cubed is not positive. And how do I know that for sure? Because I have just found an example that proves it's false. In other words, I have found a counterexample. And n equals -3 would be my counterexample. All right, let's try it again. 2 complementary angles are not congruent. Complementary means they add to 90. Well, that's false. Look, what's 45 plus 45? 90. There's my counterexample. That conjecture is false. Try again. See if we can figure out if this is correct. All right, so the statement is the monthly high temperature in Abilene is never below 90 degrees Fahrenheit for 2 months in a row. That's the conjecture. In other words, somebody looked at this table and they looked for a pattern and then they made the conjecture the monthly temperature, high temperature in Abilene is never below 90 degrees Fahrenheit for 2 months in a row. So now you're trying to test it to see is that conjecture true? Well, then you look at the table. Do you see a counterexample? Look at January and February. If you look at January and February, look, 89 degrees and 88 degrees back. January, 88, February, 89. Oh, they were wrong. It's never below, they say it's never below 90 degrees for 2 months in a row. Wrong. And there's my counterexample. Try again. For my conjecture, for any real number, x, x squared is greater than or equal to x. All right, so is that true? Well, I don't know. I've got to plug in numbers, see if I can find an example where it's not. Uh-oh, look at 1/2. 1/2 squared is 1/4. Is 1/4 greater than or equal to 1/2? Nope. So there's my counterexample. Remember, when you're trying to prove if a conjecture is true or false, what we really do is try to prove it's false. We look for an example where it's false. Here's another one. Supplementary angles are adjacent. Are they? No, that's linear pair. So look at my picture. Are those 2 angles supplementary? Yes. One is 157, the other is 23 degrees. That sums to, 180. So again, that's the conjecture supplementary angles are adjacent is incorrect, and that picture is my counterexample. Here is our last one. Show that the conjecture is false by finding a counterexample. Once again, here's your conjecture. The radius of every planet in the solar system is less than 50,000 kilometers. Well, look at the table. What do you notice? Look at Jupiter and Saturn. Yep, there's your counterexample. So the conjecture is false. Okay, so now we have a couple questions I'd like you to try to go over and see if you can remember. Let's look at them a minute here. And you can look at them and see if you can find the next pattern by using inductive reasoning. And then you can see I have the answers written for you. So you may want to take a couple of minutes and try these and see if you agree with my answers. But it's a good little lesson quiz. And that's all I have for today. Thank you so much.